Okay, so we're looking here at Patel 4G question 3C, and we're trying to solve z squared plus 4 plus 2i z plus 3 plus 2i. Now the challenge with this question is that we've got complex coefficients, but we still use the quadratic formula as normal, minus b plus or minus the square root of b squared minus 4ac, and the difficulty here is that you will end up with a complex number underneath your square root all over 2a. So when we expand and clean this up, we get z equals minus b, just leaving that for now, plus or minus, and expand this and you get 16. That's plus 4i squared, which is minus 4, plus 8i times 2, double the product, which is plus 16i, minus 12 minus 8i. And as you can see, underneath the square root sign, all the real parts cancel. 16 minus 4 minus 12 is 0, and 16i minus 8i goes to 8i. So we get left with 8i underneath the square root sign, and that's at the point where we're going to use our finding the root of a complex number. So we're then going to let root 8i be equal to x plus iy, and therefore x plus iy squared is equal to 8i, and x squared minus y squared equals 0 because there's no real part, and 2ixy equals 8i. Now obviously x and y have to be equal to each other to solve x squared minus y squared equals 0. 2ixy means you've got xy equals 4, and in order for xy to equal 4 you need x equals 2, y equals 2, or x equals minus 2, y equals minus 2. Actually it should be and, not or. There's two solutions to that, and so you get left with z is equal to minus 4 minus 2i plus 2 plus 2i, because that's the resolution of the square root on 2, and the other option is minus 4 minus 2i minus 2 minus 2i all on 2. Clearing this up, you get minus 2i plus 2i for the left hand one cancels, and that becomes real. Minus 4 plus 2 is negative 2 on 2 is minus 1 is the first answer, and the second one is minus 6 minus 4i on 2, which is minus 3 minus 2i when you simplify it.